Hi students, we were discussing the topic, the chapter 3 dimensional geometry. We have already discussed the first topic, direction ratios and direction cosines. And the next we were discussing the second topic, equation of a line in space. Okay, I hope you have studied all the equations and the conditions of a line. And today we can discuss the remaining questions of the exercise 11.2. Okay, I'll read the question. You please write the question. Question number 10. Find the angle between the following pairs of lines. Find the angle between the following pairs of lines. See, two lines are given. The first line r is equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k. And the second line r is equal to 7i minus 6k plus mu into I plus 2j plus 2k. Okay, that is vector equation of two lines. You know, the standard form of a vector equation is r equal to a plus lambda b, where a is the position vector of the fixed point and b is the vector parallel to the line. And angle between the two lines is the angle between these two vectors, b1, b2. Then what is the formula? Cos theta is equal to b1 dot b2 by modulus of b1 into modulus of b2. Okay, and here the vector on the first line is denoted by b1 and vector on the second line is denoted by b2. This is b1 and this one is b2. Okay, you know how to find the dot product. a1 b1 plus a2 b2 plus a3 b3. Sum of the product of the coefficient of I, j, k. That is 3 into 1 plus 2 into 2 plus 6 into 2, 12. Okay. And modulus of b1. Okay. How will you find modulus of a vector? Root of the coefficient of I square plus coefficient of j square plus coefficient of k square. That is root of 9 plus 4 plus 36. And similarly the modulus of the second vector b2, that is root of 1 plus 4 plus 4. Okay, that is 3 plus 4 plus 12, 19. Then okay, by adding, okay, root 49 is 7. The root 9, 3. So 19 by 21. Cos theta equal to 19 by 21, or theta is cos inverse 19 by 21. It is not the perfect value, that is enough. Theta is cos inverse 19 by 21. And in next question, question number 11, the same question, find the angle between the lines, but the lines are given in Cartesian form. In first question, question number 10, the lines were in vector form, and here in question number 11, the lines are given in Cartesian form. See, x minus 2 by 2 equal to y minus 1 by 5 equal to z plus 3 by minus 3, and the second line is x plus 2 by minus 1 equal to y minus 4 by 8 equal to z minus 5 by 4. Okay, and if the lines are in Cartesian form, from the numerator we can find the fixed point 2, 1, here it is plus 3, you have to take negative, 2, 1, minus 3. And from the second line, the point is negative 2, 4, 5. And from the denominator, we can find the direction ratios of the line. Direction ratios of the first line are 2, 5, minus 3. Or by adding I, j, k with the direction ratios, we can find a vector parallel to this line. That is, vector b1 is 2i plus 5j minus 3k. And similarly, the direction ratios of the second line are negative 1, 8, 4. By adding I, j, k with these direction ratios, we can find the vector parallel to the second line. That is, b2 is minus I plus 8j plus 4k. We got the vectors b1, b2. What is the formula? Cos theta equal to vector b1 dot vector b2 by modulus of b1 into modulus of b2. Okay, find the dot product. Dot product is 2 into minus 1 plus 5 into 8 plus minus 3 into 4. And modulus is root of 2 square plus 5 square plus minus 3 square. And modulus of the second vector, root of 1 square plus 8 square plus 4 square. And we will get the answer 26 by root 38 into root 81. We know root 81 is 9. Then we can write 26 by 9 root 38. Then what is theta? Theta is cos inverse 26 by 9 root 38. Okay. Then question number 10 and 11. Find the angle between the following pairs of line. In question number 10, the lines are in vector form, and question number 11, the lines are represented in Cartesian form. Okay, and the next one, question number 12. See, question number 12. Find the value of P. You should write the question, don't forget. Okay, write the question from the textbook. Find the value of P if the given lines are perpendicular. See, the given lines are in Cartesian form. Okay, x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. That is the standard form of equation of a line in Cartesian form. Okay, and here 1 minus x by 3, 7y minus 14 by 2p and z minus 3 by 2. Now the equations are not in standard form. Both the equations, see, these two equations are not in standard form. Okay, in standard form, the coefficient of x, y, z, the variables must be unity, that is equal to 1. And here the coefficient of x is not equal to 1. Okay, then we have to make the equation in standard form by taking the coefficient of x outside. And here the coefficient of x is not equal to 1, negative 1. By taking negative 1 outside, the first term becomes minus of x minus 1 by 3. And here also the coefficient of y is not 1. Coefficient of y is 7. We can take 7 outside. That is 7 into y minus 2 by 2p. And here the coefficient of z is 1. That is already in standard form. Okay, then negative of x minus 1 by 3, we can write x minus 1 by negative 3. Then 7 into y minus 2 by 2p, that is y minus 2 into 7 by 2p. Multiplying by a fraction means dividing by its reciprocal. Okay, in standard form, these are in the denominator. Then we can write into 7 by 2p becomes 2p by 7. Then this is already in standard form. And similarly, the second equation of a line is 7 minus 7x by 3p. See, the equation of x is not 1. What is it? Negative 7. We can take negative 7 outside. The equation becomes negative 7 into x minus 1 by 3p. And the second one, y minus 5 by 1, coefficient of y is 1, that is in standard form. And 6 minus z, see, the coefficient of z is not 1, negative 1. Take negative outside. That is negative of z minus 6 by 5. Okay, then how will you write x minus 1 into negative 7 by 3p? Yes, divided by negative 3p by 7. And the last one, negative z minus 6 by 5, we can write z minus 6 by negative 5. Okay, then now these two equations are in standard form. We can find the direction ratios. Okay, the direction ratios of the first line, negative 3, 2p by 7, 2. And direction ratios of the second line, negative 3p by 7, 1, negative 5. We got the direction ratios of both the lines. They are the denominator. Now what is the condition given? The two lines are perpendicular. If the two lines are perpendicular, we know what is the condition? Sum of product of the direction ratios equal to 0. Okay, that is multiplying negative 3, 2p by 7, 2 with negative 3p by 7, 1 and negative 5. And their sum becomes 0. Okay, then we will get the answer p is equal to 70 by 11. Okay, and this is the condition, the two lines are perpendicular. If two lines are perpendicular, you know the condition, the direction ratio, sum of product of the direction ratios equal to 0. See, the other questions are similar to the previous one. You please do it yourself. Okay, then next we can do the shortest distance between the lines. Shortest distance between the lines. We know the shortest distance means the perpendicular distance. Okay, and similar 4 questions are here in the textbook. Okay, I will do one example. You please do the other questions yourself. Shortest distance between, see, the first line, r is equal to 1 minus t into I, that is question number 17, plus t minus 2 into j, plus 3 minus 2t into k. Okay, actually, the standard constant in the equation of a line is lambda. But here, instead of lambda, the constant is t. Okay, no other change. Then first we have to write the equation in standard form. We can change the bracket, see, 1 minus t into I, that is 1i minus ti. T minus 2 into j, tj minus 2j, plus 3 minus 2t into k, that is 3k minus 2tk. Okay, then we can group the term independent of t, that is I minus 2j plus 3k. I minus 2j plus 3k. And the term in terms of t, see minus ti plus tj plus minus 2tk. We can take t, the constant t outside. Then it becomes minus I plus j minus 2k. Is it okay? Then first write the equation in standard form. And similarly we can change the second bracket and grouping the s term together and the term independent of s together. We can write the second equation as r is equal to I minus j minus k plus s into I plus 2j minus 2k. Okay, first we have to write both the equation in standard form. The first equation is r is equal to I minus 2j plus 3k plus t into minus I plus j minus 2k. And the second equation I minus j minus k plus s into I plus 2j minus 2k. Is it okay? Then from the equation we have to find a1, a2, b1, b2. You know what is a1? a1 is the point on the first line. This is a1. And b1 is a vector on the first line, that is with the coefficient. This is a1, b1. And from the second line the point is a2. This is b2. a2, b2. You know what is the formula for the shortest distance of a line? The shortest distance is a2 minus a1 dot b1 cross b2 by modulus of b1 cross b2. Now we got what? a1, a2, b1, b2. Okay, we can find the term first a2 minus a1, then b1 cross b2 and its modulus. Okay, then first we can calculate a2 minus a1. We got a1 and a2. Okay, what is a2 minus a1? Subtracting the coefficient of I, j, k separately. I minus a get cancelled. Minus j minus minus 2j, that is plus j, minus k minus 3k minus 4k. We got a2 minus a1. And b1 cross b2, that is determinant I, j, k. The coefficient of b1 minus 1, 1 minus 2. Coefficient of b2 1, 2 minus 2. By expanding using determinant, we can find b1 cross b2 is 2i minus 4j minus 3k. Then next we can calculate the denominator a2 minus a1 dot b1 cross b2. Here there is no I term, that is coefficient of I is 0. 0 into 2 plus 1 into minus 4 plus minus 4 into minus 3. Okay, their dot product is 8. And the next we can calculate the denominator modulus of b1 cross b2. Okay, this is b1 cross b2. Its modulus is root of 2 square plus minus 4 square plus minus 3 square, that is root 29. Okay, then don't forget to write the formula. The formula is the whole modulus. Distance will not be negative. Whole modulus a2 minus a1 dot b1 cross b2 by modulus of b1 cross b2. We got the dot product as 8 and modulus root 29. And answer is 8 by root 29. Okay, and similar 3 more questions are there in the textbook. Please do it yourself. Okay, thank you.